In this video, we will talk about the I2C protocol. We often see I2C and UART interfaces in the DF Robot Gravity series. DF Robot has a huge number of I2C sensors. Here, let's get to know I2C first. The I2C bus is a simple bidirectional two-wire synchronous serial bus developed by Philips Semiconductors and requires only two wires to transmit information between devices connected to the bus. The devices on the I2C bus are either masters or slaves and has a unique address, usually stated on the datasheet, through which a master can communicate with a specific slave. Generally, a microcontroller with I2C interfaces is often used as the master, and other peripheral devices are used as slaves. Theoretically, with the 7 bits addressing scheme, we can have up to 112 devices on the I2C bus. Well, how does the I2C bus work? There are two lines on I2C, SCL and SDA. SCL is the serial clock line. It generates beats by oscillating between a high and a low state at a regular interval, by which to synchronize all data transfers over the bus. While SDA is the serial data line used to transfer binary data, the high level for 1 and the low for 0. Then, how can we get these data values? They are determined by the reference intervals of SCL. This is a waveform of SDA. Now, it's hard to know what the data is without an SCL interval, but when adding an SCL, we can easily read the data according to the beat. But please note that in practice, the SDA data is sampled at the rising edge of I2C SCL. There are so many devices on the bus and so much data to be transmitted. How can we get data correctly delivered among them? Here, we made a pact. In the I2C protocol, there are start, stop, acknowledge ACK, and not acknowledge NACK conditions. A high to low transition on the SDA line while the SCL is high defines a start condition. A low to high transition on the SDA line while the SCL is high defines a stop condition. Just like other communications, one of the most important features of I2C is the perfect acknowledgement mechanism. When the slave receives the data from the master, it gives an ACK signal to tell the master, "Roger that." Well, that's all for the I2C protocol. Hope this helps you better understand how it works. So, how do we use I2C? Thankfully, the powerful open source community has provided many relevant libraries, so we don't have to do everything from the beginning. Just open the Arduino IDE, load the corresponding library, and then we can use the corresponding functions. For example, some friends asked how to use the I2C gas sensor in our comments before. Well, here it is. First, connect to the gravity port and connect to the MCU. Pay attention to the connection order. Download the library file we provided in Arduino. Find the given corresponding address. Upload it. Then you can get the corresponding data. But what if some devices share the same address? For instance, we are going to make a tomato clock with 4 I2C displays and 1 I2C clock module. But all displays use the same address. What should we do? Well, an I2C multiplexer can help. Connect the displays to the multiplexer and connect it to the main controller like this. Get the coding done. Then a tomato clock is ready for use. Do you like it? What other protocols are you interested in? Tell us in the comments and we will make subsequent videos based on your comments. Thanks for watching. If you like the video, please subscribe, like, and comment for us. And don't forget to forward our videos to your friends if you think they are helpful.